Hello and welcome back to a new video in my C++ tutorial series here on the Ludwig Fusel channel. Now in the last videos we have talked about a very important concept, but also kind of like a boring concept. We have talked about the big five. So big five, just to summarize very quickly, the idea here is that you can copy construct an object, copy assign, move construct an object, or move assign an object, as well as providing a destructor so that data is properly managed. So the whole idea is that the language can copy each object, can replace objects with move, and also can destroy objects, so that all the memory and all the internal states of the objects and memory and external dependencies are kind of like handled correctly. And that's a very important thing. We need to do this. If we don't use them, we're going to have a hell of a lot of trouble. We're going to have a hell of a lot of trouble because we're going to leak memory, and we're going to provide and write inefficient and bad and dangerous code, right? If you're writing an application, it should run 24/7, and you have a memory leak in there, at a certain point the computer will run out of memory and you just have that memory in your application. So, very important concept, but it's not really interesting. It's rather boring, and yeah, that's it. That's just how it works, but for me, really nothing is boring in a programming language, but if I would need to name the most boring thing in C++, I would definitely name the big five as a boring thing, even though it is the most important thing if you write a class. If you write a class, it's the important thing, but also the most boring thing. Except the destructors. Destructors can sometimes be fun. But yeah, what we want to talk today about is something that adds sugar to your code. So something that makes you control how the language works, how you model your code, how you write your code, and how all gets together into like working with your classes, with your objects. So really what we're today going to do is do operator overloading. So operator overloading is adding magic to your classes, to your objects, because we can overload operators. Now, normally if you're doing something with your object, for example the CNT, you have called append, right? You have called append here to append something onto that container. If you wanted to compute something from the function precacher, you have used the function compute, right? Very simple, you wrote a dot and you wrote compute. So you kind of like call the function. And that's all nice and fine. You can write your functions, you can add parameters to these functions, and everything works how it should. However, really it is not how some people like it. So for example, that append function here, right? Is it not really something that we really want to do something like add something to that? Do you really want to say not that you want to add something? So equal plus this other thing here. Wouldn't be that something that you want to do? Or like similar to the streams, wouldn't you like to stream data into that? And instead of doing multiple appends, you would rather have multiple stream operators here. Like that. Simple like that to move all the data in here. Wouldn't you like that? Wouldn't it look quite more cleaner and quite better? And the answer is yes, it would look better and it would be cleaner. Of course, it's also adding complication to your code, like a dot append. It's really meaningful what you do. If you write .append, everybody knows you're appending that to the container. If you're doing a shift, people don't really tend to get the point. Or actually, they do get the point, right? They do get the point because with cout, we are shifting something to put it into cout. So shift is kind of like always designated of moving something into a container. So shifting is kind of like this, yeah, this extinction to add something to a container, right? Because the language has given us that. People like to use their shifts. And I like to use my shifts as well, because like shifting is fun, right? I want to shift all these objects in here. I want to shift all these objects in here, and later on I want to shift that print thing itself. I want to then shift that one in here, right? That is something that I want to accomplish today. At least. We're going to do more, but that's the kind of like the basic idea. I want to make that code work. That's the whole point of today's video. And we're going to get there step by step. Now, we have already talked so much about operators. I already told you that this one in the center here, it's an operator, and you have something on the left and you have something on the right. Right? And if they are chained, you have kind of like that one. That is like one expression. It's the container. It is the move semantic for the function precacher. This is the operator. So it gets processed. That statement needs to return something. Actually, it needs to return the container again, so that we can then process that line, which should return the container as well, so that we can afterwards process that line, and afterwards that line. So really what we want to do here is we just want to kind of like use the operator here as a modeling or as an alternate version of calling functions. So really the idea here is that this operator CNT and then the shift, so the shift operator, is nothing more than a special function called on the CNT itself. And well, we actually already know how this works. The function precacher, we have already implemented some operators. Let me maybe collapse them all together because we don't really care about them. For example, here, these two functions here that were leading us to the big five. The operator assignment for a const function precacher and a move function precacher. This are operator overloads. We overloaded the assignment operator to kind of like provide a certain functionality. In this case, we provided the functionality to assign it. But everything else which comes below, like setup, compute, print, release, these are all just normal functions. They have nothing to do with operators. And that's currently fine, because currently we don't care about the function precacher. However, what we want to do is we want to write a function in the precacher container that allows us to append to the object here without calling the append function. How are we going to do this? Well, we are going to overload an operator. I always like to do this after the function itself. So how do we overload an operator? I think I already told this to you when we implemented the assignment operator. What we want to do is we always want to do something like return type operator, the operator itself, let's just say dot dot for now, the operator itself, and then we have kind of like the signature, and then we have some implementation. That's the whole idea of these operator overloads. Now, what do I want to do? Well, now I want to overload the operator shift, left shift. So shifting something into this object. Now, what do I want to shift in? Well, it's quite simple. I just want to shift that in. I want to shift in a const function precacher reference. And what do we want to return? Well, since this is a shift operator, we want to chain them. We want to return a precacher container reference. So that's basically the idea. We have an operator left shift, which means left shifting into our object. We give it a parameter, in this case a function precacher PC. And just to spoil you, later on also a function precacher move, not a const one, a move reference. And what we want to do is basically we want to take the parameter, call the append function on it, and then just return a reference to myself so that we can continue on with this operator chain. And that is actually even how simple it works. We just call the append function with the PC, and we're going to return the reference this to take this pointer and make it to a kind of like sys reference. And down here, similar thing. We want to call append, but now we want to append with std move because we want to move it. So we append std move, and we're going to again return and operate the reference this to make this operator chain working. And now, just that I have implemented these two functions, if we would scroll a bit down, you're going to see that now at this point that I've implemented these functions, these two, we do no longer have a problem here with the code. And if I would hover over that, you could actually see that it goes for this inline precacher container operator left shift function precacher PC. And actually, if you would take a look on how this function works, in the end, if you're fully optimizing your code with the compiler, you're going to actually see that this is no more than actually calling append. This is really just calling append, because this is, if I hover over this, it's giving me this little inline keyword. This little inline keyword means that this function is going to be inlined, right? You can see that it returns dereference this, and it basically knows that it kind of like passes the container along all these three twos, and it can also detect that we just call the append function. So really what the compiler is going to do, it's just going to replace this with CNT append, CNT append, CNT append, and CNT append, because it's as simple as that. And if I do this, well, the syntax here looks a bit cleaner. We have the container, and we have all these shift nicely formatted as I like to do it, and you can see how all the data goes in there, kind of like the flow with the left shift. And if I run this again, well, same result as previously, because, well, we are just doing the same code. It just looks a bit different. Now, if you start this, you can go nuts with it. We have so many opportunities and so many operators that we can overload. I don't want to go over all of them in detail, but I want to show you how you can get to there. I probably have thousands of things open that I didn't want to open. So if you take a look at C++ operator overloading, if I go to that and en.cpp reference, you can see that we have a page here for operator overloading. And really what you can see somewhere should be a big list of all operators that you could overload. I'm not really a fan of that one. Here we are. Here you can see all common operators that you can overload, like the assign operator, plus equal, minus equal, times equals, divided equal, percentage equal, and equal, or equal, XOR equal, left shift equal, right shift equal, increment, post increment, pre increment, decrement as well, plus A, minus A plus B, A minus B, so more like math operations here, logical operations not, and everything else, comparison, equals, not equals, smaller, bigger, bigger equal, smaller equal, or that one, that's a rather new one, I don't know how this is called. You can overload member access, dereferencing, address of pointer access, member access, some more access operators. You can overload function calls, comma, conditional, really anything. And actually what you can do, you can even like write own operators that convert your type to a different type. So you could convert an operator that converts your object into a Boolean, for example, checking if a computation has already been done on our thing. And really the sky is the limit. Really, if you overload all of the operators for each of the classes you're going to provide, you can really go as far as possible. Like you have, the sky is the limit. Really, the sky is the limit. You won't need everything on an object that you write. I have never seen an object in my life that really overloaded every operator. But they do at least a few of them, right? Because it's right common to do a few operator overloads. And yeah, that's really good and really really amazing. So let's actually go in here and do a few more things so that you can see what I mean. So these ones are the shift operators, quite good. Let's actually now jump back to our function precacher and think about an operator that we can implement. Well, you can see that we have used the compute function again to compute, or previously used this compute function to compute the data. However, compute is kind of like a function call, right? This is like an object and you want to now call the functions that do the computations. Well, actually, if you see it like that, you could just easily implement an operator that executes a function, right? That you just can use this object like you would execute a function. So again, same signature and the operator. Now I'm just going to leave the operator empty for now, and I'm going to show you what we do. So the compute function, operator, and what's the operator we want to overload? Well, we want to overload the function operator. So we're going to tell it what operator we want to overload. So open bracket, close bracket stands for function. And now you can see if I do this like that, it looks a bit odd with these double brackets here. However, this is one part. This is the operator. It's called operator, and the the brackets here, bracket open, bracket close, and these are the actual brackets here for the parameters. So these are like the parameters. In this case, we don't have anything in here, like no void or stuff. Like void would be more explicit, telling that we have no parameters there. But the idea here is to basically just have a very, very basic operator here. And the idea is now that what we want to do is, well, we basically just want to redirect this to compute. So actually what I've done here is I have explicitly just redirected this execution operator to the compute function, which is really, really good to do. But what we could also do is we could also make this even more fancy. We could say, okay, we're going to do another thing, another function. Same one here, same execution, same pattern, but now we're going to give it parameters. And I'm actually going to give it these parameters that we had in setup. And what I want to do is, I want to call setup xCount function, and then I want to return compute. So really, instead of like doing like two calls, we can now do it in like a single call. And this now makes our class even more versatile. What we could do here in our case here is, for example, stitch this whole .compute with just calling a function on it. Now, again, this looks a bit odd, because it looks like you're kind of like executing a function on something on an object, but that's just like, we don't need a dot, right? We can use a dot, and you could also use like the full extents and say operator that to manually call this operator. However, you don't need to. You can just treat this like this would be a function pointer, right? You have pre-charged this function pointer with xCount and the function pointer to f, and you can just use this one like a function pointer and just execute it, and it will do the stuff it should do. You could also move that one one out and move it in here, because we have overloaded the operator, the function operator, with that as well. So really simple like that. You can just take this object and say, all right, I'm going to create a default one with no data precharged, and then I'm going to just give it its data, and it's automatically going to execute for me. So really, you can build your own syntax on top of the C++ language by using the operators. And you can see that our code gets less and less like verbose, understandable, whatever you want to call it. It is hard, like especially like these execute operator, like the function calls. It's always a bit hard to tell what they really do. It's really bad, right? You cannot really tell what it's doing. I mean, it's a function precacher, so that it precaches when you execute it is kind of like makes sense, but still, just to warn you again, you can't go too deep with these operator overloads. But I'm just going to go nuts here. Personally, I wouldn't do this for the compute function, but I just want to show you a few examples, because yeah, this looks kind of like a bit odd. Right, so what is another thing that we could add to this function? Well, actually, to this class. Well, actually, you might have detected that we have no way of actually getting the pre-computed values, right? We have made a function precacher, which is now very easy, because we can pre-compute a hell of a lot of values of a function. But we have no way to actually get the values, right? We pre-compute them, we can print them, yes, but printing them is not really something that is helpful for us. We don't have really a function that allows us to retrieve them. So, well, let's actually fix this issue and add this. So what I want to do is say insert it to t, and I'm just going to call this function here add. You always like to call them add, and add is going to get a size t index. So actually, no, I had count as a inserted to t, so I'm going to use that one here as well. So this is like the index that we want to do, and the only thing that I want to do here is I return values at index. Now, if we want to do something like that, we should also be able to get the size of that container here. So how many objects do we actually have? So we would do something and return count here, so that we know how many are in here, so that we can use add and size to kind of like access the members here, right? You might have a problem with that code because it's not checking for invalid value of if values is an invalid value. This is something we're going to talk about maybe in the next or in 2 videos. I probably think the next video, because we in general need a way to catch certain conditions on our class that are invalid, like fail to allocate memory and stuff like that. These are all things that we currently don't take care of, but we should. So really, we're going to do this in the next video probably, but for now, I'm just going to write the code like that. There should be something like a to do check range if the range was matching, right? And then these functions would work together very nicely. And of course, since we are talking about operator overloads, we of course want to overload a operator for the add. So how can we overload an operator for the add? Well, we just write a function that looks very similar, but has the operator keyword. And I'm just going to leave the operator out here. Also going to make this one const, because, well, if the function itself is const, the operator can be const as well, because remember, operators are just functions. And really what we do is we just run a return add index. So how are we going to call the operator? Well, we want to access it. We want to access this like we would access the values array. So, well, the operator is, guess what? The array operator. Operator array for a 32-bit uint index gives a 32-bit number. And, oh, that's looking interesting. If I could collapse this down, why are you so ugly? I have no idea. But it looks kind of interesting why it collapses this in a weird way here. Nobody really believes what Visual Studio is doing, but yeah. So really what you can choose to is you can just write that function, and as soon as this is kind of like ready, you would be able to access that. But actually, are we able to access it? No, because C and D is kind of sealed. We have the append and print functions and now the operators as well here, but we have no way to actually access the member as well. So let's actually carry this on and also add a few of operators to the pre-cache container. Now what I always do, I always write a function that is accessible by its name, right? Because if you have a pointer, it's always a bit bad to get access to that, right? So yeah, that's really not what we want. So actually, this one shall not be const, but we can make it const. We're gonna see in a second. What I want to write here is I want to write a size function like we have did previously to just return the usage here. No, not like this, usage. However, the add operator here is now a bit more, or the add function here is a bit more... Oh yeah, of course we need to return this as an int. Yeah, right, usage. The add is a bit more complicated because we don't really know what signature we're gonna give it. Now we are counting the indices as int here, so I also should put in the index here, and I also should access the precaches at the index. So that's all not really the point in here. But the question is rather what the return value is, that one here. Because that one could be a something like that. Why? I know, because precache container, it's called function precache. There we go. It could be a function precache that we return, which would create a copy of that, which is not probably something what we want. We could make a return a reference to that, which would be good. However, then we would not be const correct, because if we are returning a reference that is non-const, we can't mark the function as const, because we are kind of like exposing a modifiable, we're kind of like exposing a modifiable instance of the function precache on a const function. So really what we want to do is we want to have this as const like that. We might have two versions of that function. We might actually have one that's not marked as const and does that so that we can have an access to both of them. So yeah, that's really the idea here, so that we can access them. And now what we of course also want is we want to of course expose these as operators, and operators here are now working the same way than they did previously. So we have the signature for the operator. Actually, now we have two signatures for the operator. That one and that one. And then we just replace the name with the operator that we want to overload. Again, in this case, the array operator, so that we can array access that. And then we can just return at index. Now, actually, what you can see is, if I would hover over then, that this is automatically using the non-const version and this one is automatically using the const version. So now it really just matters on what you want to do. So if you want to now have access to one of these elements inside the container, you can just say, all right, I want to have the first one like that, and you would have all access to it, like add, compute, or something like that. However, if you would now have like a const reference, so const pre-cache container reference, just gonna call this ref here, and you're gonna assign this to CNT. So now I have a const reference. If I would now take the reference at let's say 0, you can see that now I also have the add, print, and size as well as the operator to look at these, because this is now const. Or what I could also do is like I could do a const function precache reference, which is gonna be count at 0, right? This would also work. Then I would also have just a const way of doing it, and this should actually now also call the const operator. I'm not quite sure of that, but no, it's still actually accessing the non-const version. But that's not really the point, right? Because yeah, it's accessing thing because the precache container is not const, so it's accessing the non-const one, but then converts this non-const reference to a const reference. So really, it's juggling things around, right? And what you could do now here is could do something like for what did I call this here in 32t? I equals 0 and I smaller than CNT at 0 size. So get the size from the container and do some I++. And then I can do something like stdc out from me, and from me is gonna get like CNT 0, CNT at I, and maybe some std angle, and let me quickly again comment out that one down here. And if I would do some stuff like that, you would actually be able to echo out all the values that are in there. So we get like we have a few blank lines here, which is definitely Visual Studio's fault. At some point this console is a bit bugged. Why is it pasting so many? That is really odd why it's doing that. I can really assure you that is probably, I don't know. Really, it's I'm gonna just invoke the application manually. Simple CPP app. If I would do this like here in a normal console, you can see it's printing this correctly. I don't know what is up with the Visual Studio Debug console. Maybe I should close it. But normally it's printing that correctly. That's just Visual Studio's oddness again, not me. So really, now the sky's the limit. We have this double array access because this is the container giving us a reference to a function precacher, and then we can use the function precacher to actually get a value out of it. So yeah, now it's really simple to do it. We don't really need to put any hassle into that. It's all looking nice, it's all looking good, and we have some nice functions added to there. I also talked about on the function precacher to add like a Boolean conversion operator to convert something to a Boolean and to check that we have some data available. This is very simple. You can do something like operator bool. Now if you do something like operator bool, you are actually defining a conversion function to a Boolean. This doesn't need a return value. I don't know if it would take one. Would you take one? No, it would not take one. But if you can see, if you hover over this operator, it shows you this inline bool function precacher operator bool. So it is returning a bool. But if you're writing an operator that converts something, so this is now converting this class into a Boolean. If you are doing this, then you can like just represent the type. And I think we haven't talked about Booleans yet, but here you go. C++ has its own Boolean types, which can be true and false. Right, this is just how C was like dealing with 0 and 1 on ints. Now C++ is just doing this with Boolean, true and false, just adding a bit of naming around them. And what I could do is I could write an expression, values not null pointer. So if value is not null pointer, the operator bool is going to be true. And you could do this if you are doing some checkings. For example, I could remove the computations from the first one. If I remove the computations from the first one, there should be nothing in here. So I could like stdc out something like, let's say index 0 is my CNT at 0 converted to a Boolean. Now I'm manually, actually, you probably should already convert this to a bool without me asking, because bool is the only type that is available here. I don't know really what it's doing, but what you can do is something like you can always convert this to a Boolean, and if you're converting this to a Boolean like that, it's automatically like calling the conversion function to a Boolean since you require it as a Boolean. And if I do something like that, I'm going to expect a false and a true coming out of that. So yeah, okay, it's not really telling us false or true, it's telling us 0 or 1. So 0 for false and 1 for true. So 0 is that one because we haven't executed here. If I would add the execute back here and remove it there, we should get 1, 0 out of that. Which we do. So really, like, this is the idea of all these operators. You can convert them, have round, you can really do stuff with that, right? And now what we're going to do is we're going to dive into a whole new level of operator overloading, and a really helpful level of operator overloading. We're going to dive into the level of overloading stdc out. Now, in general, you would think if you want to overload this stdc out with your container, it would be quite easy, right? You would just write an operator in the function precacher that takes this c out, which is an O stream. Actually, it's in the container here. So actually, the idea would be that you would write an operator, something like, hey, std O stream, there we go, operator like that, and then you would take the std O stream reference, OS, and then you would do like your print. Right, in an idea, and you will return the O stream back again. Right, this would be your idea that it solves the issues. However, it does not solve our issues. Why does it not solve our issues? Well, it does not solve our issues because this operator needs to be defined for the stdc out, and the stdc out is an O stream. So this operator, to take a function precacher, needs to be defined in the class of the O stream, not in our precache container. It doesn't work if we have it here, because if we have it here, well, it is something that operates on our precache container. However, we do not want to operate on our precache container. We want to operate in our cout. And this brings us to a problem because, well, we can't modify the OStream class. It's already provided by Microsoft. You can try to edit the file, but you shouldn't do it. And you're going to screw up your Windows SDK if you do so. But really the point is you don't modify anything that comes from a standard library, from the stuff that your compiler vendor is providing you, in this case Microsoft here on my page. So what we really need to do is we need to overload this operator outside of that oStream class. And actually this is possible. You can write a free floating operator function. So what you can actually do is you can write an operator that just sits in the global namespace and converts or provides a function to print your pre-cache container. So really what you do is you write the oStream function here. So let's see the oStream reference, operator shift. And now you would normally just say, all right, it's the pre-cache. And all right, now what do we add here? Now what we're going to add here is we're going to add the left-hand side and the right-hand side. So what we need as a parameter is the left-hand and the right-hand side. So what is the left-hand side? Well, the left-hand side is everything that we have on the left. On the left, we have our std oStream reference. You could call this LSH, but I like to just call it OS for oStream. Now we have the oStream in here. What do we need on the right? On the right, we have the right-hand side. The right-hand side is our function pre-cache container. Or pre-cacher container, whatever. I don't care. Really, that is the thing that we have on the right. So that's on the right. Of course, you're going to have a reference. And of course, this reference can be const because we are printing. And the name is just going to be the PC. We don't mark any of these as const because they are not relative to an object or to a class. So they are just free-floating functions. They don't have a sys pointer, right? It's there, but it doesn't work because we are not in a class context. This may only be used inside a non-static member function, but this function is free floating, right? It is just providing a way to print. And if you can see down here, the error has already gone away. This is already working. However, it's not working at all because we don't have an implementation, and we also need to return like the oStream again. And now really what we want to do is we actually now want to call pc.print. However, this brings us to another problem. Well, because with pcprint, we are always gonna print to stdc out. Well, in this case, it's not an issue. But actually, there is something called the oStream, and the oStream is a base class. There are many streams available. There are file streams, could be network streams implemented, like really every library owner, everybody who has implemented their own library could have used an oStream or a super implementation of an oStream, so a customized class, a custom stream, to kind of like build a library. And if you then use their streams and you put your CNT in there, and CNT prints out to stdc out, you're going to have a problem. So really what you need to do is you need to adjust your print function so that it can take any oStream. So what you want to really do is you want to put an std oStream reference in here. Just call this OS, and what you're going to do is, by default, you're going to just set this to stdc out. If you do this like that, it is going to by default always print to cout. And of course you need to adjust this here so that it goes to OS instead of stdc out, and here to OS function precacher there, so that you're really going to add this to the real stream. But if you don't provide anyone, it's by default taking the cout. And if you provide something, which we're going to do down here in our operator, we're going to define the oStream, we're going to provide the oStream, we're going to provide the oStream that we got. You can then print to that specific oStream. Now there's still one piece missing here. You can see that the precachers also have the print function, which currently does not take the OS. So we also need to implement this down here. Where is my print? Here's my print. So we want to take an std oStream. Of course, it's not a const oStream, because if it would be a const oStream, it wouldn't work because we're modifying that. Not handle stdc out as the default one. Same story for that as well. And then we're gonna, instead of printing this cout, we're gonna print this to OS. Now, if you're adding all of these together, you can see that now this should work as well. And now this is like dependent at the end of the chain of what gets fed into our operator. Now, again, like everything else, the syntax is looking a bit better, but if you run it, you don't gonna notice anything different. All right, if I do like 5 and 5, the output is still the same than we had it for like 1,000 years ago. Okay, I'm gonna be a bit on the bad side here. 1,000 years ago is not that hard, but you can see like that we have like spent a half an hour to modify our codes to really look a bit different, but do the same thing, right? And that's why I call this sugar and why I call this fun. Because really what you can do with all of these functions and the proper return values and the proper operators, you can make your code readable. You can make your code stand out from the code that everybody else writes, which just uses like function coming from any other operator overloading programmer language. But C++ really does give you the limit, no limits. So the sky is the limit. You really can do everything you want with C++. And that's like the whole point of operator overloading, because like hey, this looks right clean. Very, very clean. No issues there. Alright, that's it for today's video. I hope you enjoyed. We're going to see us in the next video where we're going to talk about how we're going to handle error conditions. So, thank you for watching. See you in the next video. Make sure to like and subscribe and have a nice day. Bye.